Good morning to all. Today's session is how to do the phase lock loop in ELA communication lab. And the phase lock loop is a basic building block in communication used for frequency multiplication, FM stereo detector, FM demodulator, frequency shift key in decoder, etc. These are the applications of this phase lock loop. So now we have to know how to do the PLL practical and what is the values to measure and what is the waveform to observe. So now see the phase lock loop basic building block. And this is a phase lock loop experiment number 6. And now this is a block diagram. Why the name PLL means phase locked loop. Here the name comes itself indicating that the first block in this block diagram is phase detector. So therefore the phase locked loop, the first block in this is a phase detector, and this is a closed feedback path, is a closed loop. That's what is called as a loop. And locked, you know what is the meaning of lock and what is the meaning of capture now. So this is why this is the block diagram saying that the PLL is consisting of phase detector and feedback loop and a low pass filter and some VCO. Here the in this, what is the functions of this block diagram now see. So now this is this system is designed to some frequency. When the example and the system is designed, or we are making the tune to the frequency call as the free running frequency to the original or system frequency. Okay, so when this system is running with the one frequency call as the free running frequency, consider example 1 kilohertz for example. Now the incoming frequency is that we don't know what is the frequency of the signal of the incoming signal. Therefore here the incoming signal is coming like this, and the phase detector is used to differentiate or used to detect the error in the phases of the incoming signal and the feedback signal. So therefore here if there is any error in the phase, therefore to detect that phase, that should be coming to the low pass filter. The low pass filter eliminates the DC AC components or frequency components. It completely makes it into the DC value, and these DC value is applied to the voltage controlled oscillator. So here this oscillator is a special oscillator. It is controlled by the voltage. So the applied voltage, the error in the phase is converted into the voltage and it is applied to the VCO, and this VCO is change its frequency corresponding to the error signal frequency, error signal or a phase in the errors. And now it is checked the incoming frequency and the feedback or VCO frequency. If there is no error, then the error is 0. Therefore, the system is said to be locked. Now see that what is the meaning of phase? What is the values we have to measure? Here it is 3 domains or 3 stages or 3 states are there in this PLL. One is the free running state, second one is the capture range, and third one is the lock range. So now what is the free running state? The state 1 is called as a free running state. That is nothing but the initial or system frequency or already designed frequency of the system is called as a free running frequency. Now coming to the capture range. So now we have to measure the phase detection or phase error. Then you have to check the what is the incoming frequency. This is the signal we have to apply. The first one is called as a input frequency, or also called as a free running frequency, and this is the system frequency. Now you have to change the input frequency of the signal completely 180 degrees of phase shift. Nothing but the maximum error in the phases are 180 degrees. Therefore, we have to make the input signal completely 180 degrees of phase shift. And this is called as a lock frequency starting. That is a FL1. Here means the maximum error is there in the signal. So therefore, we have to note down this lock frequency FL1, which is called as a completely 180 degrees of phase shift. It is a complete phase error signal. Okay, and now note down the value of this lock frequency FL1, which is the input frequency or the incoming frequency, which completely opposite phase with the free running frequency. Okay, next. Coming to this, now continuously after noting this log frequency FL1, you have to change the input frequency continuously, gradually to make that the free running phase and the input signal phase completely same. Means there is no phase error. So that is nothing but the phase error is 0. Therefore, the system is, the frequency is captured. Nothing but the frequency of the incoming signal and the frequency of the system frequency, these two are equal, then it is called as the frequency is captured. So note down the frequency called as a capture frequency FC1. And next, and when we continuously increase the frequency, and automatically again the phase of the signal, incoming signal, input signal is going to change or disturb, and again it start going for the phase error in the signal. So therefore, note down that phase error, starting of the phase error, again then that is called as a capture frequency. If when there is a phase change, a small variation of phase change, then note down that particular frequency called as a capture frequency. It should be very narrow difference of frequencies coming to the FC1 and FC2. So slightly vary the input frequency, which is just to vary the phase, means a small change in the phase error. Then you have to stop there and note down the capture frequency FC2. Next, continuously goes on increasing that input frequency. Again, it is going to the completely opposite phases. That is, the phase error is maximum. Therefore, the log frequency FL2 is noted down. Therefore, with these four values, the difference of FC1 and FC2 is called as the capture frequency, and difference of FC1 and FL1 and FL2 is called as a log frequency. So you have to note down these two frequencies, and now this is a PLL measurement, and you have to go through this procedure and estimate the log frequency and capture frequency with the PLL. So this is a very important or very basic building block in the frequency modulation system. Okay.